Ever since Bitcoin first appeared, there's been this ongoing puzzle, right? How do we make it do more?
Right.
Handle way more transactions, maybe run complex things like smart contracts.
Yeah, the expressivity question.
Exactly. But without messing up what makes Bitcoin, well, Bitcoin. It's decentralization, it's security, it's that classic trilemma problem.
Absolutely. It's been there from the start. Every idea to scale or add features seemed to hit that wall you'd compromise on decentralization or security.
It felt like a fundamental limit for the longest time, just these really hard
Yeah,
trade-offs.
like you couldn't have it all.
And people have been thinking about this for ages. I mean, way back in 2013, Gregory Maxwell, one of the Bitcoin core devs, had this really interesting idea.
The bleeding edge cryptography idea.
Yes, using snarks. He thought maybe that was the holy grail, scale, programmability without breaking decentralization.
The potential was huge. Snarks, these succinct, non-interactive arguments of knowledge, the idea was you could prove some computation happened correctly off-chain.
Like proving you solved a puzzle without showing every single step.
Exactly. And verify it on Bitcoin with this tiny proof still anchored in Bitcoin security.
But the sticking point back then, the understanding was you'd need a soft fork, a change to Bitcoin's rules, just to verify those proofs.
Right. And soft forks are, well, a big deal. Consensus changes are hard.
So this amazing idea just kind of sat there for like a decade. A cool what if.
Totally. The feeling was maybe the trilemma was unsolvable for Bitcoin. Some people even started saying, hey, maybe Bitcoin should do all that stuff.
Maybe it's just digital gold and other chains handle the complex applications.
That was definitely a line of thought.
But then, boom, 2023, Robin Linus drops BitVM.
And that really shook things up.
Completely unexpected, right? It showed a way to actually verify those snarks without needing a consensus change.
Yeah, it was a genuine breakthrough. Suddenly, things like Bitcoin roll-up bridges didn't seem like science fiction anymore.
Because these bridges could let you move Bitcoin into these roll-up environments.
Think of them like layer 2s, but tied tightly to Bitcoin's security.
Offering speed, scale, more complex computation. Suddenly that trilemma looked, well, maybe not so impossible.
Exactly. Which brings us nicely to what we're diving into today.
Right. We're looking at BitSnark and Grail. These are innovations building right on top of that BitVM foundation.
Taking the concept and making it practical, aiming for scalable roll-up bridges with, hopefully, minimal trade-offs.
We've got the BitSnark and Grail papers, some BitcoinOS materials too. So our mission is to unpack these, see what they're really about.
Okay, let's start with BitSnark. Because while BitVM was huge, its strength being general purpose also created practical hurdles.
Like what?
Well, for something specific like a roll-up bridge, needing to potentially pre-generate and store billions of transactions just for challenges,
Yeah.
that's a lot.
Wow, yeah, that's a massive overhead. Like having a supercomputer when you just need a calculator for one specific task.
Sort of, yeah. BitVM could theoretically run anything, but maybe that's overkill for just verifying bridge operations.
So BitSnark comes in and says, let's focus.
Precisely. It's application specific. Highly optimized just for verifying Zscaler proofs using this interactive game between parties.
And that focus pays off.
Big time. The paper claims an order of magnitude improvement in program size, and maybe up to 50% shorter challenge response protocols for bridge stuff.
Which means cheaper and faster on Bitcoin itself.
Exactly. Plus, way simpler challenges. BitVM had, what, 6 types?
Yeah, something like that.
BitSnark gets it down to just 1. Equivocations.
Equivocations, like someone saying two different things.
Essentially, yeah, contradicting themselves during the protocol. Focusing on just that one failure mode really streamlines things.
Makes sense. Simpler means easier to check, more secure, probably more efficient too.
Definitely. Easier to audit, which is critical when you're talking about locking up Bitcoin.
So how does it actually work? This BitSnark VM, only 3 instructions. That sounds almost impossibly simple.
It's minimalist by design. That's the beauty of it. Just add mod addition with a modulus.
Like clock arithmetic.
Kind of, yeah. Bit and bit a basic bitwise AND operation.
Comparing individual bits.
Right. And equal just checking if 2 things are the same. And that's it.
But how can those 3 do complex crypto like snark verification?
That's the key insight. Those 3 are enough to perform the finite field math needed for elliptic curve pairings, which are at the heart of many snarks. It distills it down to something Bitcoin script can handle.
Okay, that's pretty clever. Finding the absolute minimum tool set. And it mentions limited registers, 256-bit ones, and immutable ones.
Yeah, the limited registers keep the VM manageable within Bitcoin script.
Yeah.
256-bit fits crypto standards.
And immutable. Registers you can't change.
Right. Their values are set at the start. It helps optimize the script implementation. If you try to change one, bam, the execution is invalid. Save some checking.
Okay, super minimal VM. How does it actually verify the proof on Bitcoin then, this interactive protocol thing? Prover and verifier.
Yeah, that's how it avoids the soft fork. It's a back-and-forth challenge game. The prover wants to prove the snark is valid. They commit to the inputs and the result.
And the verifier is watching, ready to call foul.
Exactly. If the verifier suspects something's wrong, they challenge. The prover then has to basically cut the execution trace in half and reveal the VM state at the midpoint.
Okay.
The verifier picks which half they think the error is in. They repeat this, having the disputed section each time.
Like a binary search for the error?
Precisely, until they narrow it down to a single bit snark operation. Just one add motor and bit or equal.
And that single step can be run directly on chain.
Yes. Bitcoin script can execute that one simple operation and everyone sees who is right. The cheater is exposed.
That is incredibly smart. And it's time-locked, with incentives.
Right. Each step has a time limit. If you don't respond, you lose. Stops people from stalling.
And the money part.
The prover locks up some Bitcoin. If the verifier successfully proves fraud, they win that Bitcoin.
Ah, bounty.
But the verifier also has to lock up some Bitcoin for the challenge. If they're wrong and the proof was fine, they lose their stake.
So it discourages bogus challenges too. Keeps costs down for honest users.
Exactly. It's optimistic.
Yeah.
Assume honesty, penalize dishonesty, or frivolous challenges.
And that logarithmic complexity, log n, why is that important?
It means it scales incredibly well, even for a huge program with, say, 1 million steps.
Log n means maybe only 20 challenge steps?
Something like that, yeah. The number of back-and-forth steps grows really, really slowly compared to the program size. Makes verifying complex stuff feasible.
Okay, last bit snark point. Security. It says just one honest agent can stop fraud. How?
Because of those incentives we just talked about. Anyone watching the chain sees the prover's locked funds.
The potential reward for catching fraud.
Right. So even if there are loads of bad actors trying to collude, a single honest person motivated by that potential reward can step in, issue a challenge, and expose the fraud.
So you don't need a majority, to be honest, just one watchdog.
That's the idea, the one-of-n security model. Potentially much stronger than relying on, say, 51% honesty.
Okay, BitSnark sounds like a really focused, efficient engine for snarks on Bitcoin. Now, connected to Grail, how does this let me actually use a rollup?
Right. Grail is the practical application. It takes BitSnark and builds the bridge. It's got 3 parts. BitSnark itself for verifying.
The engine?
Yep. Then a prover system to actually create these snark proofs needed.
For deposits, withdrawals, state changes.
Exactly. And the Grail bridge itself, the mechanism for moving assets securely between Bitcoin Layer 1 and the Layer 2 rollups.
And this bridge runs on operators. What's their job?
Think of them as the bridge keepers. They constantly watch both Bitcoin and the rollup chain. They help users deposit and withdraw.
And they run the BitSnark protocol.
Critically, yes. They participate in the challenge response game to verify everything. To be an operator, you register, need an active internet connection, and there have to be at least 2, but you can have many more.
Okay, so how do they help me get my BTC onto a rollup?
So you want to deposit, you essentially lock your Bitcoin UTXO on the main chain.
In one of those special taproot addresses created by BitSnark.
Exactly. The rules are set so that Bitcoin can only be unlocked later with a valid snark proof.
Okay, BTC locked on L1. What happens on L2?
The operators see proof your Bitcoin is locked on L1. The Grail smart contract on the rollup then mints you an equivalent amount of tokens. Yeah. Probably like an ERC20 token on that rollup.
So I get a representation of my Bitcoin on the rollup.
Yep. A peg token, basically.
And getting it back, bringing the BTC home.
It's the reverse. An operator on the L2 side burns their rollup tokens.
Destroys them.
Right. In return, the bridge contract gives them a snark proof saying, yep, tokens burned. This operator is entitled to X Bitcoin.
And they take that proof back to layer 1?
Exactly. They use that proof in the BitSnark protocol on Bitcoin to unlock the corresponding Bitcoin UTXOs from the bridge's taproot address.
Sounds like the operators are crucial. How do we trust them? What stops them from messing things up?
Good question. They have to register with a public key and a hashed secret. But the big thing is they have to deposit a significant Bitcoin stake.
Get in the game.
A lot of skin. If they misbehave, try to cheat, Their stake gets slashed, penalized, or taken.
Okay, that's a strong incentive. And exiting.
They can request to leave. If they've behaved, they get their stake back. But to fully exit, they have to reveal their secret key, which prevents them from rejoining later with the same identity.
Got it. The paper also mentions this operator multi-signature identity, using music too. Why do that?
It's for efficiency. The group of active operators uses Music 2 to create this shared identity. It lets them pre-sign certain common transactions together.
Like funding stakes or user deposits.
Exactly. It's cheaper and faster than everyone signing individually every time, especially in the normal non-attack scenarios. And they can also do optional things like cleaning up UTXOs or maybe simplified withdrawals if all operators agree.
Makes sense. Okay, let's walk through a deposit again, step by step, for the user.
Sure. So you, the user, say I want to deposit this Bitcoin UTXO. You ask the operators for an address.
Okay.
The operators generate that special BitSnark taproot address and pre-sign the necessary future transactions. Once enough operators sign off, it's confirmed.
Can I check this before I send my Bitcoin?
Yeah, you should be able to verify the address and the pre-signed stuff. Then you send your Bitcoin to that address on L1.
Bitcoin sent. Then what?
Operators see it confirmed on Bitcoin. They provide proof to the L2 smart contract. The contract then mints the equivalent roll-up tokens to your L2 address. Done. Your BTC is now represented on the roll-up.
Right. Now, withdrawals seemed a bit more complex. Operator-initiated versus operator-assisted.
Yeah, two main paths. Operator-initiated is when an operator has roll-up tokens and wants to swap them back for L1 Bitcoin from the bridge.
So they initiate it themselves.
Right. They tell the L2 contract, I want to withdraw X tokens. The contract burns their tokens, figures out which L1 UTXOs correspond, and internally assigns those UTXOs to the operator's L1 address.
All happening on the L2 side initially?
Yes. Once that state change is settled on L2 and ideally proven back to L1 somehow, the operator gets a ZK proof of that assignment.
The BitSnark proof.
Exactly. They use that proof on L1 to broadcast the Bitcoin transaction, moving those assigned UTXOs to their own wallet.
And there's a faster way if everyone cooperates.
Yeah, the coordinated withdrawal. If all operators are online and agree, they can just use their Music 2 key to sign the L1 Bitcoin transaction directly, skipping the individual ZK proof step. Much faster.
Okay, that's operator-initiated. What about operator-assisted? Sounds like it starts with me, the user.
It does. You want your Bitcoin back. You tell the L2 contract, I want to withdraw Y tokens to this L1 address. The contract takes your tokens and puts out a request.
Like an order on an exchange?
Kind of. An operator who has L1 Bitcoin available sees your request and says, I'll fill it. They send their own L1 Bitcoin directly to your specified address.
So they're fronting the Bitcoin?
Essentially, yeah. It's like a peer-to-peer swap facilitated by the contract. The operator earns a fee for doing this.
Ah, so it incentivizes liquidity provision for withdrawals.
Exactly. It helps users get their Bitcoin faster. Once the operator sends the BTC, they need to prove it to the L2 contract.
How?
They get a proof that their L1 transaction to you was included in the Bitcoin blockchain. They show this proof to the L2 contract.
And once the contract sees that proof,
it releases the tokens you initially deposited, plus the fee, to the operator who fulfilled your request.
okay, flexible withdrawal options. Now, these proofs, proof of transaction inclusion, proof of state transition, they sound critical.
Absolutely fundamental. They're the trust anchors. Proof of transaction inclusion verifies a specific Bitcoin transaction happened, like your deposit or the operator's withdrawal payment.
Checks it's in a block, confirmed, etc.
Right. Proof of state transition is about the L2 side.
Mm-hmm.
It proves something changed correctly in the bridge contract, like UTXOs being assigned for withdrawal or a stake being released.
And these are all SCSI snarks, Groth 16 specifically.
Currently, yes, using Groth 16. But they anticipate supporting others, maybe recursive proofs using Plotty 2 or Starks down the line.
How do you prove L2 state?
Depends on the rollup. If the rollup posts its data to Bitcoin L1 and has dispute mechanisms, the L2 proof might actually also be a proof of transaction inclusion on L1. Or it could be a direct proof about the rollup's own state, proving some data exists in the rollup state tree, which is usually tied to the rollup's block hash, like proving this UTXO is assigned to this address within the contract's data structure.
Gotcha. Okay, solid understanding of BitSnark and Grail now. Let's compare BitSnark back to BitVM again. What are the core advantages that make BitSnark better for Grail?
It really comes down to that core design philosophy, specialized versus general purpose.
BitVM is the Swiss Army knife. BitSnark is the specialized scalpel for snark verification.
Exactly, and that specialization brings benefits. Let's look at complexity.
BitVM runs RSEv32, like 55 instructions.
Yep, and each of those needs to be implemented somehow in Bitcoin script for the verification game. Complex.
Versus BitSnark's 3 instructions, addmod and bit equal, no loops, no branches needed.
Way, way simpler. Plus, BitVM needs to handle RAM 4GB of addressable memory. That means complex checks to make sure memory wasn't tampered with.
More hashing, more challenges.
Right. BitSnark. No RAM needed for its job. That whole layer of complexity just disappears.
So simpler design, fewer parts. That must mean better security. Easier to trust.
That's the argument. Fewer moving parts, fewer things that can go wrong. Only one challenge type versus 6. It's easier to analyze, easier to audit, easier to formally verify. Should lead to a more robust system.
What about the programs they can verify? BitVM sounds more flexible there. Any RSCV binary.
True. BitVM is general. BitSnark only verifies Snark verifier programs. That's less limiting than it sounds.
How so?
Because you can create snarks for almost any computation now. You can run a complex program, generate a snark proof of its execution using tools like RC0.
Which can output a Groth16 verifier.
Exactly. Which BitSnark can then verify efficiently on Bitcoin. For bridging, verifying the snark proof is often way more efficient than verifying the entire original computation step-by-step on-chain.
Because the snark compresses the proof down. Less data, less computation on Bitcoin itself.
Precisely. Huge win for bridging costs and efficiency. Maybe some niche cases prefer general purpose, but for bridges, snark verification seems like the way.
And the verification protocols reflect this difference too. BitSnark's simpler 2-phase, 1-challenge game versus BitVM's complex 6-challenge system.
Yeah, it's a direct consequence. BitSnark's focus task allows for a much cleaner, more straightforward verification protocol. Easier to understand, analyze, and implement securely.
Okay, now there was that critique of BitVM bridges by Whittle and Rindale. Concerns about getting your money out if everyone rushes for the exit.
Yes, a valid concern they raised. Could withdrawal demand exceed the bridge's processing capacity in extreme scenarios? Could funds get stuck, even temporarily?
How does Grail using BitSnark tackle that?
They argue Grail is designed specifically to handle high withdrawal demand in the normal happy path, using what they call optimistic consensus.
Assuming operators cooperate.
Right. They suggest the entire bridge's funds could potentially be withdrawn in a single L1 transaction if needed. No inherent capacity limit in that optimistic case.
Okay, but what if operators don't cooperate? The incentive unaligned scenario.
Then they rely on 2 mechanisms. First, a dynamic fee market for withdrawals. If demand spikes, users wanting out faster will bid up the withdrawal fees.
Making it profitable for operators to step in and provide liquidity.
Exactly. Higher fees attract more operator capital to service withdrawals. And second, the operator set itself is dynamic.
New operators can join.
Yes. Attracted by those higher fees, new operators can join, bringing fresh L1 Bitcoin liquidity to meet the demand. Since operators can always eventually redeem the underlying Bitcoin, if the bridge is solvent, earning withdrawal fees is presented as a potentially risk-free yield on their BTC.
So market forces and flexible membership should keep withdrawals flowing while still having that one-event security.
That's the design goal. Consistent withdrawability, even under stress.
Okay, so BitSnark refines the engine, Grail builds the bridge addressing key concerns. But then there's BitcoinOS. This sounds like the grand vision.
It is. BitcoinOS positions itself as the operating system for a Bitcoin-powered world. It builds on BitSnark and Grail, but its scope is much wider.
What's the mission?
Preserve Bitcoin's core strengths, censorship resistance, sound money, but enable almost any computation to settle back to Bitcoin security. Building a global economy on Bitcoin.
Hugely ambitious. What are the pieces?
3 main ones we know about. BitSnark, the optimized proof VM Grail, the trustless bridge, and a third piece called Merkle Mesh.
Merkle Mesh? What's that?
It sounds like a system to aggregate data from all these different connected virtual machines or rollups, and then verify that aggregated data back to Bitcoin L1. Think interoperability and data scaling.
Okay. And they hit a big milestone recently, verifying a real snark on mainnet.
Huge milestone. July 2024, block 853626. They used BitSnark to verify the first ZK snark proof directly on Bitcoin mainnet. They see it as proof of concept, the start of unlocking Bitcoin's potential.
Unlocking infinite potential for scale, privacy, programmability. How? Through ZKPs mainly.
Zero-knowledge proofs are absolutely central. By letting Bitcoin verify these proofs via BitSnark, BitcoinOS aims to enable permissionless Layer 2's rollups to flourish, inheriting Bitcoin security.
Turning Bitcoin into permaware. An OS for a decentralized economy.
That's their framing, yeah. Moving beyond just money to a foundational settlement layer.
And uniting the fragmented crypto world. The superchain idea.
Yeah, they aim to tackle that siloed blockchain problem, envisioning a network of interoperable Bitcoin rollups where assets move seamlessly, all settling back to Bitcoin L1 via ZK proofs, validated by a shared operator network.
Like one big, interconnected Bitcoin
Yeah,
ecosystem.
that's the goal. Better UX, shared security.
What are the specific benefits they're promising with BitcoinOS?
Quite a list. True L2 rollups with BTC for gas, L1 security, trustless bridging via Grail, programmable tokens beyond Rune's BRC20 with more logic, maybe cross-chain staking.
More than just simple tokens.
Right. Unified ecosystems via Slam nodes and ZK for smooth multi-chain stuff. Covenants conditional payments for new Bitcoin applications, trustless bridging across the whole OS, scalability for cheap, fast transactions, and even privacy-focused rollups.
So tackling pretty much every perceived limitation of Bitcoin today, what's the architecture look like?
4 layers. Bitcoin core at the bottom, L1 security. BitcoinOS itself as layer 1.5, execution coordination. Then the Bitcoin rollups, L2 compute. And finally, Bitcoin applications running on those rollups, L2 plus dApps.
And they claim their rollups beat other scaling solutions, Lightning, sidechains, even alt L1s.
They argue rollups offer the best shot at the trilemma. Security, scale, decentralization, better UX and decentralization than maybe Lightning's channels. Inherited security, unlike sidechains needing federations. Built on Bitcoin's proving foundation, unlike new L1s. And critically, permissionless upgrades, no need for contentious base layer changes, BIPs.
Okay. And the market impact, this trillion-dollar rotation idea.
Yeah, that's their big economic thesis. If Bitcoin, via Bitcoin, can do what altcoins do, but with better security and network effects.
Why use the altcoins?
Exactly. They think capital will flow back to Bitcoin. They point to wrapped Bitcoin on Ethereum billions locked there as potential capital waiting to come home once Bitcoin has native L2 capabilities.
So a huge opportunity for developers and businesses to build on this early.
That's the pitch. Get in early, like the early internet or early Bitcoin days. They mention Sovereign, the Bitcoin DeFi platform, is already planning to migrate to a BitcoinOS rollup.
An early example of the ecosystem building out.
Exactly.
So wrapping it up, BitcoinOS aims to free Bitcoin from its technical constraints, let it be global P2P cash, plus privacy, smart contracts, scale, potentially making other solutions obsolete.
That seems to be the ambitious goal. And all via permissionless upgrades on top, keeping the base layer stable and secure.
Well, this has been definitely a deep dive. Bitsnark, Grail, BitcoinOS. It really does sound potentially transformative for Bitcoin.
Absolutely. Bitsnark and Grail are the practical engines making rollup bridges real, optimizing proofs, providing the secure transfer mechanism.
And BitcoinOS takes that foundation and paints this huge picture, addressing the trilemma, unlocking all this new functionality, fulfilling that original promise of Bitcoin, maybe.
It certainly aims to, which leaves you, the listener, with a pretty big thought. If tech like Bitsnark and Grail can deliver that scalability and functionality without breaking Bitcoin's core, what does that really mean for Bitcoin's future, for its role in a new financial world? What does unlimited potential actually look like for the original cryptocurrency? Definitely something to chew on.